Good day. Welcome to our first physical science lesson. Today we'll be covering a section of physical science paper 2, which is rate of reaction. And if you are new to our channel, I will advise that you go through the playlist because we've got different playlists. We've got one for maths, one for physical science, and then the other playlist is for life science. So please go through each playlist. I'll be uploading each section on its own separate playlist, which I think will be a benefit when you guys have to study. And also, if you are new to our channel, I please humbly ask you subscribe, and also you can hit the like button. So without wasting any time, let's go straight to our lesson. So remember, for any reaction to occur, something needs to happen. For example, if I just have a container and I just leave this container as empty as it is, there's a big chance that nothing will happen to it. But if I were to come to the container, let's say I put water, then maybe I put let's say I put that compound, just call it carbon. Let's say I've got carbon and water inside. There's a possibility that my carbon and my water will mix or won't mix, but something will need to happen inside for the two to meet. For example, sometimes they can meet, combine to form another compound, or sometimes they won't. And we know if we to put hydrogen and oxygen in the same compound, so in the same container, we are bound to form water from hydrogen and oxygen. So a reaction needs to happen for something to occur. For something to be formed, a reaction must occur. So with chemistry, we tend to define the rate of reaction as the change in the reactants or products per unit time. So basically, remember, as your reaction proceeds, because if I'm having let's say I've got A reacting with B, and let's say this is forming AB. So in this reaction, I'm having two reactants, which are A and B. So these two reactants, they are combining together to form a new compound, which is AB. So A and this B, they are my reactants, whilst AB is my product. So always know, as the reaction proceeds, the concentration of reactants, which is A and this B, will always decrease with time because we're using them. So we're using the reactants, so they tend to decrease with time. Oppositely, the products will increase with time because I'm forming products. So they're going to increase with time. So the definition of rate of reaction is the change in the concentration of the reactant or the product with time. So when you guys do first year chemistry, they will change this a bit. Remember, since reactants, we know they are decreasing with time. So the formula will be negative change in reactant over change in time. That will be your formula for rate of reaction for those ones who will be doing chemistry next year in first year. And then for product, remember, we are gaining. So for product, it will be positive change in P over change in T. That will be for those who are keen on doing chemistry next year. So let's remember, but for grade 12, the formula is just same. You can just use a change in R or change in P. They don't really focus much on the negative or the positive sign for grade 12. So this is like the formula for rate of reaction is the change in concentration of reactant or product over change in time. Remember, by change, this means the reactant is changing. So we're going to have final and also initial. So to break down the formula, you're going to have 2 points. The other point will be final. So it will be final minus initial of the reactant or your product over change in time, also final minus initial. That will be your formula. So you need 2 points that you're going to have to work on. And then most they give you guys a graph or they'll give you a table. So from the table, you must have a final point and an initial time. For example, if I were to draw a graph, let's say I have two and I've got 4. Let's say I've got, just call it 3 here, and then let's say 5, for example. So here, remember there'll be 0. There'll be 0, that'll be down there. So here, if I were to investigate rate of fraction between 2 and 4, for example, time will be our x-axis, and then product or reactant will be our y-axis. So if I were to investigate the change between these 2 points, let's say my graph is going like this, then the point, 2 point, the 2 point, let's say, is there. The 2 point is there, and then the other one, let's say, is there. So if I were to investigate these 2 points, this here, my t here will be my final time, then this will be my t initial, the 2 will be my t initial, and then also at the same time my 5 will be my final reactant, whilst the 3 will be my initial reactant. So in the formula you'll expect something like this. It will be 5 minus 3 over 4 minus 2. That will be our rate of reaction for that graph we just did. So, and the answer we know, that will be 2 over 2, which will be 1. So that will be our rate of reaction, which will be 1. So rate of reaction will be 1. So that's basically how you can solve this type of questions. But I'm still going to do some examples with you guys at a later stage. So now, always remember, as I've mentioned, reactants will always decrease with time, and then the products or products will always increase with time. You know? So there are different ways in which you can measure reaction rate. There are 3 ways, which are the most common ones for grade 12s. So the first most common one, we tend to measure the rate of reaction through measuring the rate of formation of the gaseous product. So by measuring the amount of gaseous product that you're forming, we can get the rate of the reaction. Same thing as if you can also measure the rate of the formation of, it can be a precipitate, which will be a solid state, or also remember reactants always decrease with time, so you can also measure the decrease in mass. So these are the 3 different ways, in case we were to ask you which 3 ways you can use to measure the reaction rate. So the most common way we tend to use to measure the reaction rate is this system. So this system allows us to collect the gas that will be there in a solution. For example, I found this reaction online. For example, you can use this reaction to prove or to show how we can measure the gas. The gas that we're going to focus on measuring here is the H2, which is the hydrogen gas. No? So we're going to be focusing on measuring the hydrogen gas in our experiment. Let's say I'm having an experiment here. First thing first, there will be different sort of components you must expect. We're going to have, sometimes they use a gas syringe, sometimes they'll use a burette. It depends. Sometimes they can use a gas syringe or a burette. So you must always know there are functions, or there's a reason why we are using this gas syringe. So, and I've seen most past papers, they tend to ask you guys, what is the use, or why are we using the gas syringe? So the first function, or the first reason why we use the gas syringe, is to collect the gas. The gas you're going to form will collect through the gas syringe. So the gas here, for example, we're going to form the hydrogen gas. So the gas you're going to form here will collect through the use of the gas syringe. That will be the first function, to collect the gas. So the first function of the gas syringe is to collect the gas. The second function is to measure the volume of the gas formed. So the first is to collect the gas which is formed. The second is to measure the volume of the gas which is formed. So those 2 will be your 2 functions of why we are using the gas syringe. So I'm just going to put them down. To collect the gas. That'll be the first one, is to collect gas formed. Is to collect the gas that we formed. To collect the gas. Sorry for my handwriting. That's to collect the gas that is formed. Second one is to measure the volume. Measure the volume. Those are the 2 functions, and I've seen they always tend to ask for one here. that'll be measured. I think, yeah, this right pencil does not want to write properly, which is fine. So it's to measure the volume of the gas formed. So there's also a stopwatch. Stopwatch, or the timer, is used to give us the time. That will give us the time of how long it took for us to form the gas. And then the flask, remember the flask, or sometimes you can use a beaker. The flask, it is to store the reactants. So your reactants, they're going to put them all in the flask. So the flask will be there to store the reactants. And then the stand, remember, it will be to balance our gas syringe. That will be to balance our gas syringe. So those will be the functions of the experiment. Sometimes, also before I forget, sometimes you can also use what we call a burette. Yeah, it's a burette, or most they use a gas syringe. I remember when I was doing grade 12, we did with the gas syringe. Maybe some schools, they can use a burette or any other way to measure the gas, which is found. So I'm going to divide my videos. So for this video, I'm going to end here because I want to make the videos too long. So I'm going to do another video where I'll be showing you guys how the reaction rate is determined through calculations. Also, another video, I'm going to show you guys how to know the dependent variables, how to know the independent variables, or the control variables, because they tend to ask those questions as well. And then I will also show you guys, as time goes by, how to use the collision theory to explain the factors that are affecting reaction rate, and also how to analyze the Boltzmann distribution curve as time goes by. So I'm going to divide all these lessons in the playlist of rate of reaction. So there will be different parts, which I think it will allow you guys to follow in that order. I'll put them part 1, part 2, part 3 in the order that I'll be doing them. So thank you very much, and please don't forget to subscribe now. Thank you.